Alright, Chapter 5, Section 1. We're going to be going over prime and composite numbers. And I first want to take you to the textbook and just show you some of the highlights and things you want to write down and take as notes. So give it a second here. It's loading up. And we're going to make this full screen. Let's go back and forward. You have to refresh it. Okay, so here are some terms and definitions. You don't need to know and memorize all those, but it will be helpful. Every one that you know. This divisibility rule is going to be one of the first ones we go over. So you need to note the way that it's written. So this says if B divides A, which means you will put A on top and B on the bottom. B divides A, we write B, this vertical bar, A. This is just the notation that says B divides A. This is how they write it. This does not mean B divided by A, which they're showing you here. Okay. This actually means if B divides A, then we write it like this. A on top, B is going to be what we're dividing by. Okay. So, what this divisibility rule basically says, we have this number 20. If this number 4 divides 20, because 20 is equal to 4 times 5, we can also say that 5 will divide 20, because it's also a factor. So both of those numbers. And it's kind of like what the first problem is saying. You can kind of get that from this term factor or divisor. We're going to be looking at factorization of a number, which is breaking it down into all its factors, its prime factors. I'm going to skip over prime and composite numbers, so let's talk about that. Prime number is a natural number that's greater than 1 that is not composite, but more so is greater than 1 and it only has 1 in itself as factors. So the only way you can get that number is 1 times itself, and nothing else will multiply to give you that number. That's what we call prime. And then a number that is greater than 1 that's not prime is called composite. So that's both the prime and composite definitions. Prime number is a natural number that has exactly 2 different factors, which clarifies that 1 is not prime, because 1 times 1 is not 2 different numbers. Now here's a table of primes. It will be, I think, ideal if you were to memorize up to 50. Only the circled numbers. So 2, 3, 5, 7. All of those numbers can be multiplied by 1 in itself, and that's it. So after 2, it only consists of odd numbers, but not every odd number is prime, because you see 9 is here. 3 times 3 is 9, and 1 times 9, so it has more than 2 factors. So I memorize, or at least write them down so you can refer to them quickly. I would say the ones up to 50, those are the ones we see more often. But you do need to know or be familiar with all of these. That's why they list them here. We'll be using them. Alright, we're going to be going over divisibility rules, and these are the tests. You want to know, write these down. A number is divisible by 2 if it ends in 0, 2, 4, 6, or 8. It's divisible by 3 if the sum of the digits is divisible by 3. And so they show you an example here what they mean. If you had this big number right here, we want to know, is it divisible by 3? Then we would add up 8, 9, 7, 4, 3, and 2. Add up all those, and we'll get 33. If 33 is divisible by 3, then the whole number is divisible by 3. By 4, if the last 2 digits form a number divisible by 4, so just look at the last 2, and if that's divisible by 4, the whole number is. By 5, if it ends in 0 or 5. by 6 if it's divisible by 2 and 3. So we have to check 2 first and 3. And if it's divisible by both of those, then it's divisible by 6. By 8 if the last 3 digits are divisible by 8. By 9 if the sum of the digits is divisible by 9. So that's similar to 3. By 10 if it ends in a 0. And then by 12 if both 3 and 4. So you want to be familiar with those. We'll be using those to divide numbers or test them. Alright, prime factors. So this example is showing you what a factor tree is. They say this is a factor tree. You start with a number. You can divide it by anything that you know is divisible by. Kind of using those divisibility rules or whatever method you want to use, and you'll break it down. This number is divisible by 2, and when you divide by 2 you get 660. 2 is prime, so we circle it. And then 660 is even, so it's also divisible by 2. When you divide by 2 you get 330, so we just break it all the way down and keep going, and then we circle all those prime numbers. So the prime factorization of this number would be 2, 2, 2. So 2 times 2 times 2 times 3 times 5 times 11. So they show you that they wrote those 3 2's in exponential form. And so they got, instead of writing 2 out 3 times, they just write 2 to the 3rd power, 3, 5, and 11. Okay, and then from that, that's going to be the last major thing that we need to look at. So let's recap, and then we'll jump into the problems. See the big takeaways. Alright, you need to be familiar with this definition of divisibility. Okay, B divides A means A divided by B. B is what's going on the bottom. Alright. Got a lot of different terms that you want to be familiar with. You want to know prime and composite. Natural number that's greater than 1 has only itself and 1 as factors. So 1 time itself is the only way you get that number. A number greater than 1 that is not, that has more than basically 2 factors, 1 in itself, is going to be composite. That's just furthermore explaining that has exactly 2 factors for a prime number. 2 different natural numbers, got to be different. That's why 1 is not, because it's not 2 different numbers. Okay. You want to memorize, I would say, at least the first 50, all the first prime numbers less than 50, but you want to write these down and have them somewhere you can refer to so you can identify which ones are prime quickly. You want to know these divisibility rules, at least have them written down so you can refer to them pretty quickly. If you memorize them, that would be great. Applying divisibility rules. We're going to do that to find prime factorization. So prime factorization is breaking a number down such that when you multiply all the prime numbers, you will get that number back together. So you want to know how to do that. And then that will end the notes here. Alright, so I'm going to be using those notes to start solving these problems. So we're going to jump over to my math lab.